According to the World Health Organization, approximately 149 million children were stunted, 45 million were wasted, and 37 million were overweight. For adults, 1.9 billion are overweight and 462 million are underweight, and nearly half of deaths among children are linked to malnutrition. A serious and long-lasting problem that is being faced globally. It is caused by imbalances in nutrient and vitamin intake, commonly caused by poverty. Malnutrition hinders people from reaching their full health and potential, further affecting social and economic development. Simple students like us can contribute to the global effort in reducing world hunger, aligning with the second Sustainable Development Goal. We are students from the DLSU University Integrated School, and we'd like to ask you a question.
Have you ever heard of the idea of growing plants without soil? At first, it might seem silly. After all, almost every plant we see grows from the ground. Plants like hyacinth, orchids, and Spanish moss prove this wrong and evolved to flourish without soil. In traditional farming, the use of fields to grow crops has been prevalent throughout history. However, it is not the only way to grow plants. Another method to farm vegetables is by doing hydroponics. Simply put, it is the practice of growing plants using only water, nutrients, and a growing medium. Hydroponics come from roots hydro, meaning water, and ponos, meaning labor. This method of agriculture has many benefits. It is more efficient and faster growing than traditional farming. Hydroponics allows for the efficient use of water and nutrients, reducing waste and conserving resources, which is vital for sustainable agriculture. By enabling a year-round production in controlled environments, hydroponics can help minimize food scarcity, particularly in urban areas or regions with poor soil quality.
Through this, the Hydranimo team came up with Tara Tanim. This project was implemented for Barangay Langkiwas residents and BNS members. We invited a speaker and conducted a seminar as well as a hydroponics demonstration in the DLSU Integrated School's One Mission Park. Through the seminar, we have learned that hydroponics is more than just planting without soil. It is a revolutionary approach that addresses and encourages food security, economic development, and environmental sustainability.
After carefully identifying areas for improvement, we present to you Hydrobot. This project aims to improve the existing hydroponic setup, which relies on constant manual monitoring of crucial variables like temperature, humidity, water level, pH, and electrical conductivity. A manual monitoring process poses challenges, especially for people with busy schedules. The researchers decided to utilize technology to create a more efficient approach to monitoring hydroponic systems. The scope of our study is to design, develop, implement, and evaluate an Arduino-based monitoring system, our Hydrobot. Furthermore, the Hydrobot is tailored for simple nutrient addition program, SNAP, hydroponics, which is a low-cost method created by the Institute of Plant Breeding at UPLB. The Hydrobot has the purpose of assisting in maintaining hydroponic systems by alerting the owner of unfavorable temperature and humidity conditions and prompting them when adjustments for pH, EC, and water levels are needed. The study's prime objective is to assess the effectiveness of integrating the Hydrobot in ensuring ideal growth conditions for lettuce in SNAP hydroponics. Additionally, the Hydrobot is also cost-effective. Its components have a much budget-friendly price compared to buying separate commercially available instruments.
The Hydrobot consists of the following components: Arduino Uno, THD11 sensor, pH sensor, TDS sensor, water level sensor, piezo buzzer, LCD I2C, and the LED bulbs, all of its purpose and create an optimal monitoring system design.
Even a small action can make a big difference in a world where malnutrition is prevalent. Through the Hydrobot, we can promote hydroponics as an initiative for better and sustainable farming. To further improve the efficiency of the Hydrobot, future researchers may automate the dispensing of acid base, nutrient solution, and water into the hydroponics setup. Future projects may also consider widening the scale by partnering with local government units and schools. The Hydranimo team believes that hydroponics can spark many more opportunities and contribute to the overarching goal of sustainable agriculture and food security.